Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding multiprocessors. At the end of this video, the student will gain knowledge regarding what is multiprocessor system, how it is different from single processor system, and what are the tightly coupled and loosely coupled multiprocessors with examples. And the topic learning outcome can mapped with the course outcome of summarize the concept of pipelining and interprocess communication for advanced processor design. And the topics that are discussed in this video are introduction, characteristics of multiprocessor, the types of multiprocessors, and taxonomy of the multiprocessor systems. Generally, the computers can employ the functional units like input unit, central processing unit, which is having 3 subunits, the memory unit, arithmetic logical unit, and control unit, and the output unit. So here a computer can have a single processor system. In order to support single tasking, one user can able to execute a single task at a time using these uniprocessor systems. As a contrast, in a multiprocessor system, more than one processor can be employed in order to execute multiple tasks simultaneously, thereby supporting parallel processing. So, the concurrent execution of various tasks can be carried out with the help of multiprocessor systems. So, a multiprocessor is a computer that have multiple processors. So, a single computer with multiple processors can be generally referred as a multiprocessor system. So, it is possible that the processor in the multiprocessor system can communicate and cooperate at various levels of solving a given problem. So here, if one instruction, the instruction generally executed in the steps. In order to provide required functionality, the user has to supply the program. A program is collection of instructions. The instruction can be executed in a various steps. So here the instruction cycle generally consists of fetch the instruction, decode the instruction, fetch the operands and evaluate the effective address, execute the instruction. These are the 4 steps of the instruction execution. So in a multiprocessor system, one instruction is in fetch cycle at the first clock tick of the control unit. In the second clock cycle, the first instruction can move to the decode step of the instruction execution. In the meanwhile, the second instruction can enter into the fetch clock cycle. And at the third clock signal, the first instruction can move to the calculation of effective address and fetching the operands, and the second instruction can move to the decode step of the instruction cycle, and the third instruction is initiated the fetching of instruction. So in this way, multiple instructions can be concurrently executed with the help of multiprocessor system. So the communication between the processors take place by sending messages from one processor to another or by sharing a common memory. So 2 major aspects can be considered in the multiprocessor system. The processors can be communicated with the help of message passing technique or with the help of shared memory technique. So this parallelism or concurrent execution can be achieved by the multiprocessor system uh, and in a single processor system by employing multiple functional units. The concurrent execution of instructions can be possible. So one of the parallel processing tasks can be achieved with the help of the multiple functional units, which can help in the multitasking execution. So generally, a single processor system can have a single arithmetic and logical unit. This unit is responsible for performing all arithmetic and logical operations. But with a system with multiple functional units, can have separate multiplication function unit, division function unit, floating point addition functional unit. So which will help the computational speed, the increase of computational speed, thereby the throughput can be increased. So here is the example of a processor with multiple functional units. So here the adder subtractor is one single unit which can perform the integer addition and subtraction. The next unit is the integer multiply, which is used to perform the integer multiplication. Next, logic unit, which is used to perform various logical operations like AND, OR, exclusive OR, etc. Next is shift unit. The shift unit can perform the logical shift, either right shift or the left shift, as well as arithmetic shift and circular shift. Next, incrementer can use it to increment the content, register content or memory content by 1. Next, floating point add and subtract functional unit can be used to perform floating point addition and subtraction. Similarly, the multiplication and division can be carried out with a separate floating point multiply, floating point divide functional units respectively. So here the task has to be divided into subtasks and each operation can be carried out with a specialized functional unit for that particular task in a multitasking system which is having a multiple functional unit. This is the one way to perform the parallel execution of the instruction. And the next method is for concurrent execution support is the pipelining. So pipeline processing is an implementation technique where arithmetic sub-operations are the phases of a computer instruction cycle overlap in execution. So this pipelining concept can support the arithmetic sub-operation or arithmetic processing or calculation or computational capabilities, or in order to execute the instruction, the phases of the instruction can also be concurrently executed with the help of pipelining concept. If it all the pipelining concept that is applied for the arithmetic sub-operation execution, those pipelines can be referred as arithmetic pipeline, and if the pipelining concept can be applied for the execution of phases of a computer instruction cycle in a overlap fashion is referred as instruction pipelining. So the pipelining technique of decomposing a sequential process into sub-operation. The computational task can be divided into small parts. So each sub-process being executed in a special dedicated segment that operates concurrently with all other segments. So here each sub-operation can be executed in a segment and these segments can be operated and can share data among other segments while execution of the instruction. So why these functional units and pipelining concept can be used means at a single point of time more than one instruction can be executed by the computer. So the number of instructions executed per unit time is generally referred as the throughput. So if throughput is increased, which in turn increases the performance of the computer. So the purpose of parallel processing is to speed up the computer processing capability. So the amount of processing that can be accomplished during a given interval of time is referred as the throughput. So the amount of hardware increases with parallel processing, so the cost of the system is also increases. The performance increases, but the parallel execution requires special hardware, so which in turn the cost of the system can increase. So what is the multiprocessor systems? So most computers are single processor or uniprocessor systems. However, multiprocessor or parallel systems are increasing in importance nowadays. Why? Because multi-user, to support multi-user operating system, multitasking operating system, multiprocessor systems are recommended. Nowadays, all cutting-edge technologies of the computers generally are the cloud computing applications, or big data applications, or blockchain applications, or cyber security applications. All these computational incentive applications. So they require the parallel processing or concurrent execution of the instructions. At the same time, it has to support multiple user needs and can involve in computational incentive applications, and large volume of data processing can be required for these applications. So most of the applications can involve in engineering and scientific notation of data processing. So thereby the multiprocessor systems are nowadays in a great demand. So these systems have multiple processors working in parallel that share the computer clock, memory bus, peripheral devices, etc. So the processors are more than one, and that can share the all other resources of computer clock, memory, bus, peripheral devices in the parallel processor systems or multiprocessor systems. So how this architecture of the multiprocessor system. So here this is the processor. This is one processor. The processor is 8086 processor, and the second processor is the co-processor. It is a 8087 processor. So here more than one processor is present in this architecture. But these processors can share the common clock as well as bus control logic, so that the bus arbitration has to be controlled with this logic. The memory unit and IO unit can be shared with these processors. So this is the common multiprocessor architecture. What is the advantages of these multiprocessor systems? So these multiprocessor systems are more reliable system because multiple processors are employed in these systems. If one processor is failed, then the other processor can share the load of the processor so that the system can give functionality to the user. So it cannot degrade the system. The entire system does not fail, but it can somewhat slows down, which is generally referred as graceful degradation. So in a multiprocessor system, even if one processor fails, the system will not halt. So it has to provide the functionality to the user. So this ability to continue working despite of hardware failure is known as graceful degradation. So with the help of these fault tolerant environment for the application, the multiprocessor systems are more reliable systems. And the next advantage is enhanced throughput. Just now we discussed that the amount of work that can be done in a unit of time can be increased with the parallel processor or multiprocessor system. Thereby, it increases the throughput of the system. And the next advantage is more economic systems. Multi-processor systems are cheaper than single processor systems. So why? Because they can share the data storage, peripheral device, power supplies, etc. So from the common architecture of multi-processor system, so here the processors, more than one process are employed, but these processors can share the common resources of clock, bus logic, memory, I/O. So here these processors can share all these resources so that it is a more economic model of the processor architecture. So these are the advantages of the multiprocessor systems. What are the disadvantages of multiprocessor systems? So here some increased expense if multiple or more than one processor has to be incorporated in a system, so which requires some special hardware attention. Next, complicated operating system is required. So more than one task can be executed in a multiprocessor system. So it has to support more than one user at a time. So the coordination and control and how the data can be shared, how the resources can be shared between these multiple processes can be taken care by the operating system. So more advanced operating system which can support the multiple user multitasking operating systems can be needed for the multiprocessor systems. And large main memory required. Why? Because each processor is working on large computational and data intensive applications. So they require the large memory. So these are the disadvantages of the multiprocessor systems. Now we have to discuss about what are the characteristics of multiprocessor system. So a multiprocessor system is an interconnection of two or more CPUs with memory and input-output equipment. So there should be a more than one CPU can be present. This is the first characteristics of multiprocessor system. Next, the term processor in multiprocessor can be either a central processing unit or an input-output processor. So all peripheral devices, that means the input units, input devices and the output devices can be connected to a single processor, that is called input-output processor, for control and arbitration of various input and output devices. So if a system can employed with more than one CPU or more than one IOP, those can be considered as the multiprocessor system. Next, multiprocessors are classified as multiple instruction tree, multiple data stream system. So, the flying classification can give multiple instruction and multiple data stream as one type of parallel processing computer. So, if it are multiple instruction stream and multiple data stream employed in a computer, that computer is referred as MIMD architecture. Those systems can be the multiprocessor systems. So, with this multiprocessor system, the multiprocessor system can support parallel computing. So, concurrently, the instructions can be executed with the help of multiprocessor system. Either it can be in arithmetic computational operations or with the instruction execution cycle. Next, distributed computing. So here it involves the usage of network of processors. So the processors cannot be centralized. They can be located geographically diverse locations and can be connected via a network in order to execute distributed applications. So distributed computing can be supported with the help of multiprocessor systems. Next characteristic is supercomputing. So this involves the usage of fastest machines to resolve big and computationally complex problems. So these multiprocessor systems generally used for the computational incentive applications, engineering and scientific applications. So almost recent technologies in the computer science and engineering can use the parallel processing system in order to support the supercomputing capability. Next characteristic is vector computing. So it involves the usage of vector processes wherein operations such as multiplication are divided into many steps and are then applied to a stream of operands. So the computational task can be first segregated into small subtasks. So each operation can be executed in a segment. So if you take a multiplication operation, it can be divided into many steps and each step can be applied to a stream of operand so that concurrent execution of the arithmetic operation can be carried out. So these are the characteristics of multiprocessor systems. So how the multiprocessor architecture can be? So here if you consider this is a 4 CPUs are employed in this architecture. This is core 1, core 2, core 3, core 4. These cores can have the individual separate memory for each CPU and can share the common memory, that is the shared memory. If at all their processing can involve any storage, then they can be supported in the individual memory. If one processor is communicating with other processor, the shared data can be placed in between, the common data can be placed in the shared memory. So these processors, these cores can communicate with each other with the help of shared memory so that the common data can be placed in this shared memory. And with the bus interface, it can be connected to the off-chip components. So this is the multiprocessor architecture. So this is the internal layout of the multiprocessors. So this is the one core and this is the second core. So in this, the multiprocessor can support more than one processor for concurrent execution of instructions. What are the types of multiprocessors? There are two types. One is symmetric multiprocessor. Second one is asymmetric multiprocessor. So what is symmetric multiprocessor? So each processor contains a similar copy of operating system and they all communicate with each other. So same operating system can be maintained in each and every processor. So all the processor in a peer-to-peer relationship. So the communication can be taken place in a one node to another node interaction so that the peer-to-peer relationship can be exist between the processors. An example of symmetric multiprocessing system is the Unix operating system. So what is SMP, symmetric multiprocessor architecture? So here these are the processor 1, processor 2, etc. processor n. Each processor can have internal cache, L1 cache, and they are communicating and connected with the system with L2 cache. And this is the main memory and IO subsystem. So they are, the processors can be communicated and can be shared the main memory and IO bus. and they can communicate with a technique of message passing. So those type of architecture is generally referred as symmetric multiprocessor architecture. What is asymmetric multiprocessor architecture? In asymmetric systems, each processor is given a predefined task. There is a master processor that gives instruction to all other processors. So, in between the processor, there exists a master-slave relationship. One processor can act as a master processor and can give instructions to all other processors. Asymmetric multiprocessor systems contains a master-slave relationship, but symmetric can contains the peer-to-peer relationship. So, how the architecture of the asymmetric multiprocessor? So, here this is the master processor. The processor 2 can act as the master processor. The processor can give instructions to all other processors. The processor 1, 3, 4 can act as slave and can execute the instructions that is issued by the master processor, processor 2. So, this is called the asymmetric multiprocessor. Now we have to discuss about what are the differences between the symmetric and asymmetric multiprocessor. So, in a symmetric multiprocessor, processing of programs by multiple processors, they share a common operating system and memory. So, here the memory and operating system can be shared by all the processors. But in case of asymmetric multiprocessing systems, they can have the function that has to be according to the master-slave relationship. One processor can act as the master and give instructions to other processor. In case of symmetric multiprocessor, all the processors are treated equally. So that's why the peer-to-peer relationship can exist between processors in symmetric multiprocessing system. But in case of asymmetric multiprocessing system, processors are not treated equally, so that master-slave relationship can exist between the processors. Next one is processor can take process from the ready queue, such as process can have separate ready queue. So here the process can be taken in the ready queue, which can have the all resources supplied so that they can execute. So each processor can have a separate ready queue. But in this asymmetric, the master processor assigns processor to the slave processors. Only the master processor can employ the ready queue, so that depending upon the ready queue operation, the master processor can give instructions to the slave process in case of asymmetric multiprocessing systems. In symmetric systems, processes communicate with each other by the shared memory. In case of multiprocessor system, they can communicate with master processor. So, two techniques can have to be used, either message passing or the shared memory. In case of asymmetric multiprocessors, all processors have the same architecture, but it is a different architecture in case of asymmetric multiprocessors. Not an easy to design or handle the symmetric multiprocessors, but here easier to handle the architecture in the asymmetric multiprocessor. So, comparatively the costly, they are the symmetric multiprocessors are the costly, asymmetric are the cheaper. So these are the comparison factors that can be taken between the symmetric and asymmetric multiprocessing systems. So if you take the architecture in the symmetric multiprocessing systems, so here CPU 1, CPU 2, CPU 3 can has to be shared memory, and the process can stored in the shared memory can be executed. So the peer-to-peer relationship can be exist between the processors. But in case of asymmetric multiprocessing, here one processor can act as master, the other process can be slaves. So here no shared memory is there. They can communicate with the help of message passing technique. Now we have to discuss what is the taxonomy of multiprocessors. So here first the processor organizations can be classified as 4 types by the Flynn. So the 4 types of architectures are single instruction data stream, so SISD. Second one is SIMD, single instruction multiple data stream. Third one is multiple instruction single data stream, MISD. Fourth one is multiple instruction multiple data stream, MIMD. So in the single instruction single data stream, these are the uniprocessors. And in case of single instruction multiple data stream, they can be used for vector processing, array processing, so that the task can be divided into subtasks and can be carried out with parallelly with various operands. And in case of MISD, they are not practically employable. Next architecture is MIMD, which is multiple instruction multiple data stream. They can be considered as the multiple processors. So they can operate on 2 techniques generally, the shared memory technique and the distributed memory technique. So in the distributed memory technique can employ the clusters so that the data can be shared between the various processors. In case of shared memory technique, 2 categories are there. They are symmetric multiprocess SME, non-uniform memory access, NUMA. So this is the taxonomy of the multiprocessors. So what is the Flynn classification? The classification can be depends on the distinction between the performance of control unit and the data processing unit. How instruction stream and data stream can be employed in the computer depending upon the 4 types are described by the Flynn. The first one is single instruction stream, single data stream computers. And next one is single instruction stream, multiple data stream. Third one is multiple instruction stream, single data stream. Next one is multiple instruction stream and multiple data stream. One of the major characteristic of multiple processor system is the multi-processor system can support MIMD architecture, so that multiple instruction stream and multiple data stream can be employed in the multi-processor architectures. Now, what are the loosely coupled processor and tightly coupled processor? So, loosely coupled processor is a type of multiprocessing system. So, there is a distributed memory instead of the shared memory. So, all the processors has to be connected to the distributed memory. In a loosely coupled multiprocessor system, the data rate is very low. And in loosely coupled multiprocessor system, modules are connected with MTS, Message Transfer System Network. So, the communication between processors can be accomplished with the technique of message transfer. So, how this loosely coupled system architecture is described here. So, here the basic technique that can be used to communicate is message transfer system, MTS. So, here this is the computer module 0, which can have its own memory and IO and can execute the processor. And second module can have its own processor and their IO and the memory, local memory. But these processors can communicate via the message transfer system. Those systems are generally referred as the loosely coupled system architecture. Now, what is the tightly coupled architecture or the processors. So it is also one type of multiprocessing system, and here it uses the shared memory technique. So tightly coupled multiprocessor system data rate is high. Why? Because all processors are sharing a common memory. So in tightly coupled multiprocessor system, modules can be communicated through PMIN, IOP, ISIN networks. So by using these network protocols, the communication between multiprocessors can be carried out. So how this tightly coupled system architecture. So here this is the processor 0, processor 1, 2 processors. With the ISIN protocol, these processors can be communicated, or with PMIN they can communicate with the memory, and with the IO pin they can communicate with the IO devices. But here they are using the shared memory modules. So the memory module can be commonly shared with the help of PMIN with all the processors. So these processors, this type of multiprocessor architecture is the tightly coupled system architecture. Now we can distinguish between what is the tightly coupled, what is the loosely coupled architecture. So tightly coupled multiprocessor system contain multiple CPUs, therein connected at the bus level. Okay, but the CPUs may have access to the with a memory hierarchy with both local and the shared memory. But in case of loosely coupled systems, they can communicate with the message passing system. Next, tightly coupled system perform better better than the loosely coupled systems. So here, as a contrast, the loosely coupled system is just opposite of the tightly coupled system. So the performance can be low in the loosely coupled system. So the cost is expensive in case of tightly coupled system, and it is less expensive in case of loosely coupled system. In a tightly coupled system, the delay is experienced. Why? Because the message sending and the acknowledgement can take the time. In case of the loosely coupled systems, the intermissions can has to be delayed large due to the slow data rates. And here in the tightly coupled system, the system's multiple CPUs that are connected to a printed circuit board, so that they can share the same memory. And here, for example, if you take two computers connected by a 2400 bit per second modem, so that the messages can be exchanged with the help of this modem. So that is the example of loosely coupled system. The tightly coupled system tend to be much more emergency efficient than the clusters. So the data can be stored as clusters, so that whenever required they can exchange between the processors. In loosely coupled systems, they use components that were not necessarily intended to specifically for use of such systems. So these are the various factors that can be used for comparison of tightly coupled and loosely coupled multiprocessors. So in this video, we used these references, the textbooks of Maris Mano, Computer System Architecture, and William Stalling, Computer Organization and Architecture, and the web resource. Third one is the web resource. These are used as the references. So this video majorly focused on what is the multiprocessor, why parallel processing is required, and what are the types of the multiprocessor system, what are loosely coupled system and tightly coupled system, with comparison of both. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.